In 1915, Einstein published his theory of general relativity, which explains how gravity affects space and time. Today, more than 100 years later, scientists like NIST's Junyi are still undertaking research that proves his theory is correct.
I love playing with lasers and atoms. This is Strontium-1 clock. This clock is 50 times more precise than our previous clocks, which holds the world record.
Inside the clock are 100,000 strontium atoms, layered like a stack of pancakes about a millimeter high. The clock is so precise that when Jun's group divided that stack in two, they could measure how time was passing in the top of the stack and the bottom of the stack and see a difference.
Gravity slows time down. As we get closer to the center of the Earth, time slows down. And that's a time dilation effect predicted by Einstein's general relativity.
This isn't the first time scientists have proven Einstein's theory. They have compared clocks on the ground to clocks on airplanes, then to clocks on satellites. The higher clocks went, the faster they ticked. And as our clocks improved, we could see time change at shorter and shorter distances, most recently down to the level of atoms in Strontium-1.
This is clearly a new measurement capability that we have never done before. And when we say we, meaning the humankind. And this really is the first time in a laboratory that we can measure time dilation effect across distance of a millimeter.
So why do we keep making even more precise clocks?
Time and gravity is connected. So as we continue to improve clock precision, we can use this to explore and measure the changing Earth. Imagine if we can make a bunch of these strontium clocks, put them around the perimeters of Yellowstone. We may be able to tell when the Yellowstone might have a volcano that's coming up, and so we can warn people how the global warming is causing glacier to melt, for the sea ocean level to rise, or maybe the massive body of underground water is migrating.
And for physicists, these new clocks can bridge the gap between the quantum world and Einstein's theories.
Strontium-1 can measure time dilation effect across a few hundred microns. But if we push another factor of 10, when we start to measure time difference across a few microns, now we start to probe the connection between quantum physics and general relativity, a very microscopic view of the world and a very macroscopic view of the world. That part, Einstein might find very surprising. That would be a completely new realm of physics for us to explore.
What else will these improved clocks teach us? Only time will tell. Learn more at nist.gov/physics.